Finding the value of k using the discriminant by Paula de Alba, Natalia Gince, Alexa Morales, Tere Ortiz, Isabel Ariaga. The discriminant comes from the quadratic formula. In the quadratic formula, you can see that there is a square-rooted part, b squared minus 4ac. That is the discriminant. In the discriminant, you can have three solutions: one solution, two solutions, or no solution. When you have one solution, the discriminant has to be equal to 0. When you have two solutions, the discriminant has to be greater than 0. And when you have no solutions, the discriminant has to be less than 0. So that means a negative discriminant.
This is the procedure to find the value of k by using the discriminant formula.
Now we're going to look at our problem. Our problem is x squared minus kx plus 3 minus k equals 0. So by looking at these, we need to find our a, b, and c. So our a is going to be 1. Our b is going to be negative k. And our c is going to be 3 minus k. So now we have to plug this to our discriminant formula.
So this is going to look like k squared minus 12 plus 4k. And then you're going to organize the terms, so it's k squared plus 4k, and then minus 12. You're going to factor this trinomial, k and k, and then factors that multiply each other give me 12, but subtracting gives me the one in the middle, that's 4. So it's 6 positive and 2 negative. So k is going to be minus 6, 2. And that's it. These are the values of k, and this is the procedure for one real root.
Now we're going to find out if k meets the requirements for two real roots, which means x is greater than 0. So, let's rewind and remember that we have a number line that represents both numbers that k is. From left to right, it reads as negative infinity to negative 6, and then 2 to positive infinity. So, what you're going to do now is make a table. The table is going to be divided by 3 different numbers. One that is less than both of your numbers, one that is in the middle of both numbers, which is usually 0, and then one that is greater than both numbers. Now, let's plug in our numbers in the top of the table. It will be parenthesis x plus 6, then close parenthesis, and parenthesis x minus 2, which must be greater than 0. What you're going to do is substitute the x for the numbers that were said before, one that is less than both numbers. Now, when you plug in the negative 7 in the x's, you're going to find out that, negative 7 plus 6 is going to give you a negative number. Then you multiply that by negative 7 minus 2, which is also going to give you negative, which means that the equation is going to be positive, and that is greater than 0, which means that this is true. Then you're going to plug in 0. If 0 plus 6 gives you positive and then 0 minus 2 gives you negative, the answer multiplied is going to be negative, which means it's not going to be greater than 0, which makes the equation false. Then you plug in 4 into the equation, and 4 plus 6 is going to give you positive, and then 4 minus 2 is also going to give you positive, and multiplied, the answer will be greater than 0, which means that the equation is true. Now you have that k is equal to negative infinity up to negative 6 union 2 to infinity.
So, if these are the values of k, that will give us two real roots. The graph would look something like this. Because as you can see, it crosses the x-axis 2 times, meaning that it has two real roots. To find the values of k that give us 0 real roots, we look to the chart and see which ones are false. In this case, they are the values in between -6 and 2. Those are the values of k that will give us no real roots. The graph would look something like this. So the values of k that will give us no real roots are open parentheses -6, comma, 2, close parentheses.